Okay, we're going to do a demonstration of some waves. So what I have here is a ripple tank viewed from top down, and there is a vibrating right here, just this straight line piece of plastic basically, and it's causing the waves to ripple. The distance between each of these black lines or darker lines is a crest, we'll say. So this is a waveform moving to the right. Now what I'm going to do is I'm going to turn this on to sync, and you'll see that it just stays fixed, right? That's basically the light source is now fixed in one place. It's a bit easier for us to see things. So what we're going to do is we're just going to test out a few different wave phenomena. So opening this up, I'm going to replace in a little piece of metal here just to create a bit of reflection. So I'm going to drop this down again. And sure enough there, once it settles in a moment, we can hopefully see that the waves are coming in and they are being reflected away when they hit this barrier here, and they're actually being reflected in this direction down. And you'll notice the distance or the size of the waves this way is the same as the incoming wave. It doesn't change the shape of the waveform. So that's reflection. I've now replaced in the a block of glass in here, and you can see the refraction, just the slight bending of light as it goes from one medium to the other. It's more obvious in person here. As I look at the screen, I see that it's not super obvious, but hopefully you can see a little bit of a bending of light there, or bending of the wave. Much more obvious when we do it with light, doing Snell's law later on. Diffraction. Okay, what we have here is difficult to see, but we have a wall or a barrier and another barrier here. We have our wave front approaching this, and when it hits the barrier, you can see it's actually getting spread out in circles here. Now, how much it gets spread out depends on how close it is to the size of the wavelength incoming. So if I try to, this gap is about that big there, you can see it's quite a big gap. I'm going to try to bring it closer together to more the size of the wavefront. So, and there we can see it's still not greater see, but it's definitely produced a much stronger diffraction here, or greater diffraction. So diffraction is when it spreads around a gap or through or around an obstacle. So we can even just take it with one obstacle and just put this in its way. We should see some diffraction there, and sure enough, we can see it's not as obvious though, but there's some spreading of the wave here as it goes around. Okay, so once it hits an obstacle and goes around it, the wave spreads out. So what we have here is there's vibrating at two different points now. And let's close it over. E. And we're getting this lovely interference pattern going on. So what we have here is we've got 2 point sources vibrating, sending out concentric circles at each. And you'll notice there's bright and dark regions, okay? And where the dark regions are, it depends on how you want to talk about this, but let's say the darker regions are destructive for argument's sake, okay? So you can see that there ends up being this, see this bright line coming out here. If you just imagine a straight line there, a straight line there, a straight line there, continuing down, you can almost see it traced out. That is where they are meeting and they're forming a constructive interference. So the waves are overlapping with a crest and a crest, or a trough and a trough, which is causing constructive interference, which would amplify the wave. In the other regions where it's not doing it is destructive. Okay, so we have here two waves, two coherent sources producing constructive and destructive interference. Right, I'm going to use this to also just show us a polarizer. So using the light here, I have two polarizing lenses here, and what I'm doing is one of them is a vertical and one of them is horizontal. Now we don't know because it's too close for us to see, but if I overlap them, it seems like nothing happens. So whatever way I have them now, maybe they're both vertical, right? Now if I rotate one of them, you'll notice bing, it cuts out the light coming through there. Okay, so I've now polarized the light, limiting it to one, well, limiting it now to no plane, but here I'm limiting it to one plane, reducing it from its original either way. So there's polarizers in action.